Hi, this is Nathan Melcher for exam or demonstration 3 of Math 3A. So the first question asked to take a question from exam 3 that you get 100% on and redo it. So I chose exam 3, question 8. I did get part A correct, but I'll just briefly go over it. It asks where this is continuous and where it is differentiable. It is continuous along the entire axis, including at the point, since the points are filled in. It's not the reason it's continuous is because visually there's no breaks or separations. The reason it's not differentiable, this fails, differentiability fails, because there's a sharp turn at -3, 2 at this point right here, and that makes it differentiable based off the second condition when checking for differentiability. Part B, this is the part where I got wrong, and the question lists off the different function information about the function, and the student claimed that the local min and max would be at -1 and 1. So I took those that data and put it into my own and drew a number line. You've got -2 and 2. So if you actually look on this side over here, hold on one second. All right, sorry about that. So you've got this number line right here. And so I did the calculations, and over here on the left side, it's in a negative direction, it's decreasing. In the middle, it's increasing, and on the right hand side, it's decreasing once again, which means that these points here are actually where the change occurs, not at -1 or at 1, -1. It's actually at -2, 2. So this is the local mins here. Then for question 2 on the demonstration, it asks you to make an equation and solve the quadratic formula or the quadratic polynomial and apply Newton's method in order to find out the true answer of radical 5. So this was the formula that I created of P5 is rad 5 equals 0 is x squared is -5. I started with my first guess at 1. The formula to increase a guess is if we were to write this out, it's x of n is equal to x n minus 1 of f of x of n minus 1 over the f prime of x of n minus 1. So what I did on this one here is this one here is x1 is equal to x0, f of x0, f prime 1 or f prime x of 0. So for our x prime is 1, so we have 1 minus f1 of f of 1, f prime 1 of 1. So if you plug that in up here, you've got 1 squared minus 5 and so on and so forth. Move all the way down, you've got 3. So our x1 is going to be equal to 3. Move down here, x2 is going to be 3 minus that. Move over, 2.3 repeating, approximate. x3, 2.3 repeating, fill that in. We end up with x3 is equal to 2.380, which is what it has to do. Use 3 iterations to find the approximation. And rad 5 is equal to 0.2360. So we were the absolute error was 0.002, and we were told to find within 0.01, 0.01. So 0.002 is less than 0.001, means it's an acceptable margin of error. Alrighty, that's it for exam number 2. And thank you, Professor Carrillo, and enjoy your holidays.